Hello everyone. Today in this video, I'm gonna tell you about a specific, very important topic. But before that, I just want to have a diagram first. That is the workflow. Maybe here we have a problem, and with this problem, what we can do is we train ML algorithm. After that, what happens is we get a solution. We inspect it. In the sense, we evaluate. After evaluating, we understand it better. After that, we again iterate if it is needed. We again repeat the same if it is needed, and we again approach to the problem again. So this is a flow. Here, while training an ML algorithm, we need to check if the data provided is enough or not. So we need to make sure whether we are actually providing enough data to our algorithm or not. That's the important thing we need to consider here. So first of all, we have a problem. Before training the algorithm itself, we need to think whether we have enough data to feed our algorithm or not. After having enough data, we need to feed that enough data to our machine learning algorithm. Then the algorithm is trained on that particular data and it provides you the solutions. We need to inspect it or we need to evaluate it. After inspecting or evaluating, we'll have a better understanding about our data. Then afterwards, we need to repeat the same process if it is needed. Then again, we need to approach the problem. Again, we start training and so on. Okay. So it is the usual flow of it. But here, I want to tell you something. I'm just taking the spam filter as an example here. Okay. I'm taking the same example. It is the spam filter. For example, take the spam filter. So once if spam filter is trained on enough data, if spam filter is trained on enough data, then after training it usually gives you the solutions, and it can also be inspected to know. It usually, after getting trained, it detects words or phrases that is nothing but the patterns. It detects the patterns here. These patterns are the good predictors of spam. These patterns are the good predictors of spam here. Okay. So now after detecting what happens, this will usually help to know unexpected. After our ML algorithm detects these phrases and patterns, this will help our algorithm to understand about this helps in understand unusual unusual in the sense not so frequent, I mean not so suspected, unusual correlations or new trends in the data. Okay, then what happens? Okay, we have a spam filter. We have trained our algorithm with enough data, and it detects some words or phrases, or it has detected some kind of words or phrases. With that, it has decided these words and phrases are the good predictors of the spam. What happens if it is after detecting that these are the good predictors of spam? It usually helps in understanding unusual correlations or the new trends that are being involved in the data. What happens if we understand it? If we understand the data better, what happens? If we understand the data better, then we can solve. Then we can solve the problem. Easily. When you don't understand the problem at all, you can't really solve it in an easy manner. But you can only solve it when you understand it completely. Okay. So here, this is the scenario, and I also want to tell something. I want you all people, I want you all to apply this ML techniques to know about large amounts of data. So what I'm saying is, if you just apply this machine learning technique to the large amounts of data, that's the huge data or big data, then what happens? What we get is, it usually finds out the patterns which are not usual, which are not usually visible. So we can easily detect unusual patterns when we have huge data, and when we apply ML techniques to those huge data, we can easily find out the patterns which are not usually visible in our data. Okay, this entire process is nothing but we call it as data mining here. See, we have a data, and if we apply these techniques to find out some, uh, new patterns, then it is nothing but known as data mining. That's all for this video. I'll see you in the next video. Take care. Jai Hind.